DSPy employs Pydantic's data validation framework to establish structured data models for airline customer service operations. This approach ensures type safety and schema consistency across the agent's workflow. We are about to examine how these models are defined to represent core entities such as dates, user profiles, flights, itineraries, and support tickets. The implementation leverages Pydantic's BaseModel to create validated data structures that will be used throughout the agent's reasoning and acting processes.
From Pydantic, import BaseModel. Class date BaseModel. Hash somehow LLM is bad at specifying data time, so. Hash we define a custom class to represent the date. Year, int. Month, int. Day, int. Hour, int. Class user profile BaseModel. Userid, str. Name, str. Email, str. Class flight BaseModel. Flighted, str. Date time, date. Origin, str. Destination, str. Duration, float. Price, float. Class itinerary BaseModel. Confirmation number, str. User profile, Flight, Class ticket BaseModel. User request, str. User profile.
This code defines a set of Pydantic data models for an airline customer service system, establishing a clear data structure that will be used throughout the application. The models represent core domain entities including date, user profile, flight, itinerary, and ticket, each with precisely typed fields that enforce data validation and structure. The design follows a domain-driven approach where each model encapsulates specific business concepts. For instance, date handles temporal data with year, month, day, and hour fields, while flight contains all necessary flight details including origin, destination, and pricing. The itinerary model composes these by referencing both user profile and flight, creating a complete booking record. This composition pattern enables clean separation of concerns while maintaining relationships between entities. Using Pydantic provides several advantages: automatic data validation, serialization/deserialization capabilities, and clear type hints that improve code maintainability. The models serve as the foundation for the system's data layer, ensuring consistency across different components. This approach is particularly valuable in an airline service context, where data integrity and clear relationships between entities are critical for operations like booking, cancellation, and customer support ticketing. Let's break it down.
From Pydantic, import BaseModel.
Imports BaseModel from the Pydantic library, which provides the base class for creating data models with type validation and settings management.
Class date BaseModel.
Defines a class named date that inherits from BaseModel, establishing it as a data model with validation and serialization capabilities provided by the base class.
Class user profile BaseModel.
Defines a class named user profile that inherits from BaseModel, establishing it as a data model with validation and serialization capabilities provided by the base class.
Class flight BaseModel.
Defines a class named flight that inherits from BaseModel, establishing it as a data model with validation and serialization capabilities provided by the base class.
Class itinerary BaseModel.
Defines a class named Itinerary that inherits from BaseModel, establishing it as a data model with structured fields and validation capabilities.
Class ticket BaseModel.
Defines a new class named Ticket that inherits from BaseModel, establishing it as a data model with validation and serialization capabilities provided by the base class. These Pydantic models form a clean domain-driven foundation for airline customer service operations. Each class inherits from BaseModel, gaining automatic validation and serialization while maintaining strict type safety. The date class handles temporal data with explicit fields, while user profile and flight encapsulate core business entities. The composition pattern shines in Itinerary, which combines user profile and flight to represent complete bookings, and Ticket, which links user requests to profiles. This layered approach ensures data integrity across the system, with Pydantic's validation preventing inconsistent states. The design prioritizes clear relationships between entities, crucial for operations like booking management and support ticketing, all while keeping the codebase maintainable through explicit type hints and structured models.
The ticket clutches a user profile, but drops the flight, leaving the itinerary to chase its own shadow.